जय हिंद एंड वेलकम टू द इंटेलेक्चुअल इंटरप्राइजेस ऑफ कंप्यूटर साइंस। तो आज से हम लोग शुरू कर रहे हैं अपना कंप्यूटर साइंस का जो कंप्यूटर ऑपरेटर ग्रेड ए का सिलेबस है उसको हम कवर करने की शुरुआत कर रहे हैं। तो अगर आप इस कोर्स को साथ जुड़ना चाहते हैं और कंप्यूटर साइंस के सिलेबस को कवर करना चाहते हैं तो हमारे साथ जुड़ जाइए, हमें फॉलो कर लीजिए। तो कंप्यूटर साइंस है क्या? वेल, इट इज अ फैंसी वे ऑफ सेइंग दैट कंप्यूटर साइंस इज अ साइंस ऑफ कंप्यूटेशन। It is a tool by which you can solve problems, you can solve real world problems. You can turn some in, you have some inputs, and by applying some logic, some algorithm, you convert into some meaningful outputs. अगर आप ये सोचते हैं कि कंप्यूटर साइंस का आपके लिए यूज़ नहीं है क्योंकि आप ये दूसरी स्ट्रीम से हैं, आप ह्यूमैनिटीज़ से हैं, तो आप गलत हैं। कंप्यूटर साइंस इज़ फॉर एवरीबडी। इट हैज़ नो स्पेसिफिक डोमेन ऑफ इट्स ओन। इट इज़ अप्लाइड टू ऑलमोस्ट एवरी फील्ड लाइक मेडिकल, लॉ एनफोर्समेंट, travel and tourism, everywhere. Computer science is everywhere. So you should study computer science, and you should study not to acquire a job but to gain knowledge and understanding. So with that said, computer science is the science of problem solving and computational thinking. Everybody should learn how to program a computer because it teaches you how to learn methodically, how to think methodically. जैसे कि आप लोग देखेंगे, आप लोग अगर जुड़े रहेंगे तो आप लोग जानेंगे कि कंप्यूटर साइंस आपके सोचने की तरीके को डेवलप करता है। अगर आप प्रोग्राम करते हैं तो आप चीज़ों को अलग नज़रिए से देखने लगते हैं। सो यू शुड लर्न कंप्यूटर साइंस। आपने कभी ना कभी सुना होगा कि कंप्यूटर अंडरस्टैंड्स बाइनरी, जीरो और वन। सो बाइनरी क्यों कहते हैं? बिकॉज बाइनरी इट हैज ओनली टू डिजिट्स, टू स्टेट्स, जीरो और वन, ट्रू और फॉल्स, ऑन और ऑफ। बट ironically, only with these two values we can represent almost any type of information in a computer. We can represent numbers, characters, audio, video, images, and almost anything you may think of. So as we humans, we choose a decimal number system. Decimal, why decimal? Decimal क्यों कहते हैं? Because deca means tens. In our number system we have 0, 1, 2 up to 9 digits. But a computer uses only binary. Binary has only two digits. Binary because by meaning two. It has only two digits, 0 and 1. सो कहने को तो ये 0 और 1 है, लेकिन कंप्यूटर असल में एक इलेक्ट्रॉनिक डिवाइस है। इसके अंदर हम लोग 0 और 1 तो अपने कहने के लिए कह दिया, लेकिन 0 और 1 इसको रियल में रिप्रेजेंट कैसे करेंगे कंप्यूटर के अंदर? तो कंप्यूटर एक इलेक्ट्रॉनिक डिवाइस है, उसके अंदर इलेक्ट्रॉन्स फ्लो कर रहे हैं। जब हम कंप्यूटर को सर्किट बोर्ड के अंदर प्लग करते हैं, पावर ऑन करते हैं, तो उसमें देयर इज ए फ्लो ऑफ इलेक्ट्रॉन्स। So you may think of light bulb. Suppose it is a light bulb, and if its switch is not on, then it is in one of the two states. It is in off state. But as soon as we switch on this bulb, it may light up. So this single light bulb can represent two states or two values, on or off. But in a computer, instead of light bulbs, transistors are used. There are millions of transistors in a computer nowadays. Millions of transistors are closely packed in an IC, integrated circuit. So by using these voltages, we can represent these values. A low voltage or absence of charge means a 0, and a high voltage or presence of charge is represented as a 1. So we all know, we from our childhood in our primary school we are taught to understand numbers. If I write a number like so, read it. Your answer must be 123. But how do you know that it should be read as 123? Because there is an algorithm in your mind that you do not think much of it. You just jump to the answer and say that it is 123. In our grade school, we are taught about the place value system. So, as we humans, we use decimal number system. So, this number can be written as 1 into 3, 10 into 2, 100 into. We can write this number as 1 into 3 plus 10 into 2 and 100 into 1. Or we can also write it as 10 to the power 0 into 3 plus 10 to the power 1 into 2 plus 10 to the power 2 into 1. We can also write like this. So you can see we are in the decimal number system. We are using the powers of 10 to the power 0, 10 to the power 1, 10 to the power 2, and we multiply the given number of each digit of that number with the respective power of 10. So why we do it? Because we are using decimal number system. We have base 10. Base 10. So जैसे हमने इस नंबर को इंटरप्रेट कर लिया कि ये 123 है, इसी तरह से हम बाइनरी नंबर को भी अंडरस्टैंड कर सकते हैं. सो बाइनरी और डेसिमल में फर्क क्या है? फर्क बस ये है कि डेसिमल में हमारे पास 10 डिजिट हैं 0 through 9, और बाइनरी में केवल हमारे पास 2 डिजिट होते हैं 0 और 1. बट विद दैट 2 digits only we can represent any number no matter how small or big. So if I may ask, how you represent the number 1 in binary? Sorry, first of all, let's see how you may represent the number 1 in decimal. So 1 in decimal is obviously 1, or we can say 001. But if we have to represent number 1 in binary, how can we represent number 1 in binary? If you said 1, then you are right. We can represent it like this. binary. We can represent the number 1 in binary like this or like this. If we have to represent number 2 in decimal, we can write something like this in binary. So we cannot write 2 in binary like this because we have only 2 digits, 0 and 1. So what can we do? As we saw earlier, in decimal we use powers of 10. So by that logic, in binary we use powers of 2. So if we have to represent binary, in binary the number 2, we may write it like this. First of all, let me draw a binary chart. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, and so on. So if we have to represent a number like 1, we may, and if we have you see we have 4 bits here, 4 bits, binary digits, 4 bits, binary digits. So if we have to represent the number 1, we can write it as 1. 2 to the power 0, everything to the power, anything to the power 0 is always 1. So 2 to the power 0, 1, 1 into 1, 1, and anything multiplied by 0 is 0. So it is converted into a 1. If you have to represent 2 in binary, you can write this is 2. How? You can calculate everything to the power 0 multiplied by 0 is 0, and 2 to the power 1, 2 into 1, 1, 1 plus 0, 1. 2 to the power 1 is 2 into 1, 2 plus 0 is 0. We have to represent 3. This is 3. 4. This is 4. 5. This is 5. Are you able to follow the pattern? Now, if we have to represent 6, this is the number 6. 7. 7. 8. 8. Now 9. Try to follow the pattern. 9. 10. 8 plus 2. So we have to put a 1 at the 8th position and a 1 at the 2nd position, so that their sum will be equal to 8. This is 8. Oh, sorry, this is 10. 11. 11. If we have to represent 12, 8 plus 4, 12. 13. This is 13. 14. 14. 15. This is 15. But what we do if I have to represent number 16? We will require an additional bit. If we have 2 to the power 4, then only we can represent a bit. 16. The number 16. 2 to the power 4 is 16 and everything is 0. 16 plus 0 is 16. So if we have 4 bits, how the highest number that we may count in binary is 15. 0 through 15. So this is the binary number system. We humans, we use decimal number system, but computers, they are an electronic device, so they use binary number system. Binary number system has only 2 digits at their disposal, that is 0 and 1. You may ask why computers use binary? Because it is easy for a computer, for an electronic device to represent information in binary, because it has only 2 discrete states, either a 0 or a 1, a high or low, on or off, true or false. That is the reason that computers uses binary as their primary language or binary number system. Now let's talk about algorithms. We will be diving deep into this topic later in the course. The topic number system. We shall cover this topic deeply later in the course. But today it is an orientation class, and I want to give you only a flavor of what is coming in next few months. So we talked about algorithms. But what is an algorithm? As we saw, computer science is the art of computation, science of problem solving. We use various techniques to solve real world problems. There is a misconception. People think that computer science is programming and vice versa, but this is not the reality. Programming is just a tool in your arsenal. Computer science is a very vast subject. So, what computers typically do? We have, in order to solve problems, we have some inputs and we feed that inputs into the computer, and somehow magically it converts those inputs into outputs. It converts that raw information or raw data into some meaningful information. And how computer did it by processing or applying some logic on that input. Computer give out some meaningful output. So how we achieve that? How we achieve meaningful outputs from some raw input? We do so by applying some logic or some algorithms. Algorithm is a fancy way of saying to achieve something, applying a step-by-step approach. So algorithm is nothing but applying several steps in order to solve a problem. So for example, everybody have in their life use a dictionary. Dictionary is a book containing lots of words and meanings. So in a dictionary, words are arranged in an order, in ascending orders of English alphabets. So for example, A comes first, B comes later, C later, and in this way words are arranged in a dictionary. So if we have to say find the meaning of the word sort. If we have to find the meaning of this word in a dictionary, the meaning of sort in dictionary, how may we do so in a dictionary? There are several ways that we can find the meaning of this word in a dictionary. First way could be we pick up the dictionary and open each and every page one by one. We are searching for the meaning of the word sort, and we are going to search this word in a linear fashion by turning every page one by one. So assume that this dictionary contains 1000 or 2000 pages. So in our first algorithm, what are we doing? We are searching for the word sort, but we are doing it in a linear fashion by turning from start every page one by one. Now, is this algorithm correct? Yes, it is correct. By turning every pages one by one, we can reach the page in which there are numbers starting with S. This algorithm is correct, but it is efficient. No, it is not, because it will take a very long time to reach to the page containing the number starting with S if we do it like this. Can we improve this algorithm a bit? Yes. How? We can do slightly better. Instead of turning every page once, we can flip 2 pages at once. Now, is this algorithm faster than the previous one? Yes, it is faster than the previous algorithm. In fact, it is twice fast as the earlier one. But is this correct? No. What if the word we are searching for in between those pages, we may skip over it? So, what can we do? Can we do something better? Yes, we may. What? As we know that in a dictionary, words are arranged in a sorted order. So, what is the meaning of sort? Sort means to arrange something in some order, either in ascending or ascending order. मतलब sort का मतलब क्रम में लगा हुआ. So as we already know, we have this information that in a dictionary words are arranged in a sorted order. So what can we do? Suppose that this dictionary contains 2000 pages and we are searching for the word sort. Then we can do something like this. We can open to the middle of this dictionary and we see if sort is on the page that we have opened. If it is there, then we can check the meaning, and if it is not, suppose we opened at M. So what does it mean? It means it is clear that the word sort must be on the right hand side of this dictionary because S comes after M. So for us, size of the problem become half because S must be on the right hand side of the dictionary. We repeat the same process again. We again open in the middle of the book of this dictionary and we see where we have got So we have got like this time R. So what can we do? We tear half this dictionary. In first iteration, if we have 2000 pages, the size of our problem is 2000. In the second iteration, size of the problem becomes 1000 pages. In the third iteration, it becomes 500. So we repeat those steps one by one, and in last we should arrive at only one single page, and we will check it. If thought is in this page, we will check the meaning, and if it is not, we shall give up, and that we may conclude that this word is not in the dictionary. So what we see, that this third algorithm is dramatically faster than the earlier two algorithms, because if you have followed the first algorithms in a 2000 page dictionary, then in the worst case, if that word is at the last of the page of the dictionary, you have to take 2000 steps. So this algorithm was correct, but is certainly not as efficient. But in the second algorithm, if we fill it 2 pages at a time, then it may take only 1000 steps in the first case, if it is on the last page. But if we apply the third algorithm, the size of the problem decrease very dramatically. At the first iteration, we have 2000 pages. Next iteration, 1000, 500, 250, 125, something, and so on. The size of the problem decreases very dramatically. So we can say the third algorithm is correct and a faster way of doing things in this scheme of things. So I hope you understand what is an algorithm. I want to tell you that there is no one way of doing things. You may achieve the same thing by applying different algorithms. Every algorithm may have some pros and cons, and you have to analyze those factors and choose the best according to your condition and situation. We shall take another example. Suppose we have to go to Delhi from Lucknow. We have a problem. We have to travel to Delhi from Lucknow. How can we do it? Let's think about different ways or say algorithms to achieve this. We can travel by on foot. We can use a train. We can use our private car, or we can take a flight. We have different ways, all of them are correct, but each one of them has some pros and cons. If we analyze this on the factor of cost, then this is the cheapest. It is costlier, most costly, and it is costliest. But our primary condition, if our primary condition is not money, if it is time, then this algorithm is worst. This is average. This is, we can say, average, and this is the fastest. We can analyze these algorithms on the basis of comfort. If we take comfort into account, then by traveling on foot from Lucknow to Delhi is worst. It may be best if you are using your private car or by aeroplane. This is average. So you see, to solve a problem, to achieve something, we have different ways. Like for example, if we have to travel from Lucknow to Delhi, we have very different things. So no algorithms. There are a number of algorithms for the same problem, but it is upon you to choose according to your deciding factors which algorithm is correct to use in the ideal condition. So by this point I am assuming that you learned what is algorithm. If you have any problem, you can ask in comments. Now, let's talk about pseudocode. Pseudocode क्या होता है? Pseudocode. What is pseudocode? Pseudocode कुछ नहीं है, जब हम एल्गोरिदम को बिना किसी प्रोग्रामिंग लैंग्वेज के यूज करें, सिंपल इंग्लिश या और किसी भी ह्यूमन भाषा में अपने शब्दों में लिखते हैं, तो उसको pseudocode कहते हैं. जैसे जो हमने डिक्शनरी वाला एग्जांपल देखा, अगर हमें उसको स्यूडो कोड में एक्सप्रेस करना हो तो हम उसको कैसे लिखेंगे? स्यूडो का मतलब ही होता है फॉल्स और फेक, यानी कोड है नहीं, बस कोड जैसा दिखता है, स्यूडो कोड. दिस इज समथिंग that the step-by-step instruction that you write in your own language without using any programming language, without using a computer. So if we have to search for the word sort in a dictionary, what would be the steps? Like pick up the dictionary, then we are writing the pseudocode for the third algorithm. Open to the middle. Okay. Now next, look at words. उसके बाद if sort is among words, check meaning. else open to the left of middle, open to the middle of left of the book. Go to लाइन 3। मतलब अगर आपने पहली बार किताब को बीच में से खोला, अगर शॉर्ट वहां पे है तो मीनिंग चेक कर लीजिए, अगर नहीं है तो फिर से लेफ्ट में खोलिए और लेफ्ट में खोलने के बाद क्या करना है, गो टू लाइन 3 यानी लुक एट वर्ड्स, इफ शॉर्ट इज अमंग वर्ड्स चेक मीनिंग, अगर नहीं तो फिर एल्स ओपन to the middle of right of the book. You have no need to write it down. I am just showing you what is pseudocode and how you can write it. अगर तब भी नहीं तो so this is the pseudocode for the third algorithm that we have used in order to search for the word sword in a dictionary. Pseudocode is nothing but writing down the step-by-step instructions in any of the human language, be it in Hindi, English or any other language. One thing to note here is that computer is dumb machine. It only performs those tasks that you told it. If you need to instruct the computer to open the television, then you have to tell him all these steps. नहीं तो क्या होगा, रोबोट फ्रेम में चिट्ठी से कहता है टीवी खोल दो तो टीवी तोड़ के खोल देता है। तो ऐसे ही कंप्यूटर है, जितना बताओगे उतना ही करेगा। तो आपको उसको हर स्टेप बाय स्टेप बताना होता है कि टीवी अगर उसको ऑन करवाना तो आपको बताना पड़ेगा कि टीवी की पावर कॉर्ड को वॉल सॉकेट में लगाओ, उसके बाद मेन स्विच ऑन करो, फिर रिमोट से ऑन करो। अगर आपने कह दिया कि टीवी खोल दो तो वो तोड़ देगा, तोड़ के खोल देगा। तो कंप्यूटर इज कम्प्लीटली डम, यू हैव टू इंस्ट्रक्ट इट एवरीथिंग इन स्टेप बाय स्टेप। So now let us see a graph of the algorithm that we have seen. Suppose it is x-axis and this is y-axis. It is time to solve and it is size of the problem. Sorry for my handwriting. The graph of the first algorithm, in which we are searching for the word in a linear fashion, would be like this. It will take n steps in the first case. For the second algorithm, the graph is slightly better, but is n by 2 in the first case. But for the third algorithm, the graph would be like this. It is log n. So you see, if the size of the problem is increasing in the first algorithm, time to solve is increasing proportionally. In the second algorithm, if the size of the problem increases, time to solve is increasing proportionally. But in the third algorithm, if size of the problem is increasing at a certain point, no matter how big the problem is, it will not take much time in comparison to the other algorithm. Suppose that in the dictionary, if there are 2000 pages, then in the first case it will take suppose that 8 steps. But suppose we double the size of the dictionary, 4000 pages. But now that third algorithm will take only one step more. If it is taking 8 steps earlier, now it will take only 9 steps. If we double the number of pages in dictionary once again to 8000 pages, but that algorithm will take only one more step, that is 10 steps. So this is how much efficient this third algorithm is. And in computer science, such type of algorithms are known as divide and conquer algorithms. Divide and conquer algorithms. So today we have already seen what we have seen. We have seen number one, we have learned what is computer science. Now, if someone asked you what is computer science, you can say it is the science of computation or the science of problem solving. Computer science is not programming. Programming is just a tool to solve problems. And everybody should learn computer science because it teaches you how to think methodically. It greatly improves the way you think. It teaches you to think more logically and more efficiently, as you may see later in this course. We learned about number systems, decimal, binary. This is the number system that we humans use, and this is the number system that the computers use. It has only 2 digits, 0 and 1. But we have already seen that we can represent any big number, any largest number using only these 2 digits. We have seen and we have learned what are algorithms. What is algorithm? Algorithm is a step-by-step set of instructions to solve a problem. We have seen what is pseudocode. Pseudocode is nothing but writing down an algorithm in a piece of paper or using a computer, for example, notepad or a wordpad, writing down these algorithm or step-by instructions in a human language, not in any programming language. When we do so, we call it pseudocode. One more thing that we should learn today are flowcharts. फ्लोचार्ट्स क्या है? फ्लोचार्ट्स कुछ नहीं है, जैसे हम लोग एल्गोरिथम को जब अपनी भाषा में दर्शाते हैं उसको स्यूडो कोड कह देते हैं। जब इसी को हम लोग चार्ट मतलब ग्राफिकल वे में दर्शाते हैं तो उसको फ्लो चार्ट कह देते हैं। चलिए इसको भी देख लेते हैं। मान लीजिए हमें दिखाना है कि चेक करना है कि नंबर ऑड है या इवन, तो उसको कैसे हम लोग चेक कर सकते हैं। अगर इसको हम फ्लो चार्ट की मदद से दिखाएं तो फ्लो चार्ट में कुछ सिंबल्स का यूज करते हैं। जैसे इस सिंबल का यूज करते हैं, ओवल है ये, ओवल इसका यूज करते हैं स्टार्ट स्टॉप में। जब कोई इनपुट आउटपुट लेना होता है तो इसका यूज करते हैं, इसको कहते हैं रोम्बस। जब हमें कोई डिसीजन लेना होता है तो इसका यूज करते हैं, इसको कहते हैं डायमंड। सो आज काफी हो गया है, काफी लंबा क्लास हो गया है। फ्लो चार्ट से को हम लोग कल देख लेंगे। आज हम लोग ने इतनी सारी चीजें देख ली। अगर हम लोग कंप्यूटर ऑपरेटर ग्रेड ए का सिलेबस देखें तो देखिए जो पहला जो सिलेबस है, देखिए एल्गोरिदम, नंबर सिस्टम, फ्लो चार्ट, इसको हमने आज देख लिया है। ये नहीं कह रहा हूँ मैं कि इसको हमने पूरा कंप्लीट कर लिया है, लेकिन एटलीस्ट वी हैव एन आइडिया व्हाट आर दोज थिंग्स एंड वी हैव लर्नड हाउ कंप्यूटर internally represent information in its memory. So I think it is more than enough for today. We shall see you in the next class tomorrow. All the best. Thank you. Jai Hind.